Hi everyone, and thank you for joining. Let's work together on algebraic solutions of some reflections over the y-axis. Remember that a reflection about the y-axis is also known as a reflection of the x-coordinates. And the reason why is because that when the y-axis becomes the reflection line, the original point will go to the other side of it, switching the x-coordinate to opposite and keeping the same y-coordinate. So that's why it's a reflection of x. So reflection line is the y-axis, and this is a summary of the notes that we took today in today's lesson. Now, the y-coordinates as a result will remain the same, whereas the x-coordinates will change to opposite. Now, algebraically speaking, we're going to say that the y values do not change, but the x values will change to opposite, and that's why we have a minus in front of x. Now, the invariant points are always located on the reflection line. And because the reflection line is the y-axis, then invariant points will be on the y-axis. Or in other words, there will be the y-intercepts of the relation or the function or the graph in general. So therefore, to find the coordinates of the invariant points, which are again on the y-axis, I wanted to think about it. So any point on the y-axis will have one coordinate the same, and that would be the coordinate x. So we're going to set x equal to, and x will be exactly equal to 0. And then we evaluate y. The invariant points then will be in the form x equals 0 and y is whatever value we'll get from the evaluation, so this value. So we're going to take a look first at the quadratic function 2x squared minus 7x minus 4. We'll write the reflection equation, or the equation of the reflected function, and we'll determine the invariant points. So since the reflection is about the y-axis, it means that we are building f of negative x. So what that means is that if we have f of x in here, maybe I should bring this down here. Let's use a space. So if x has become negative x on the left side, then these x's on the right side will also become negative x's. So we have 2, and I see x. That will become now a negative x. Remember to keep this in brackets. It's a very common mistake students make. And the reason why would be because x is being squared. So negative x now will be squared. And that's why we need to keep it in brackets. And now minus 7. I see x again. That means that I have to replace it with a negative x and then minus 4. So simplify this a little bit more, and we'll have negative x to the power of 2 is positive x squared. So this is 2x squared. Now, negative with a negative will make a positive, so positive 7x and then minus 4. So this would be the equation of the function f of x reflected over the y-axis. Now we have to find the coordinates of the invariant points. So for invariant points, we're going to say they are always on the reflection line. So that means on the y-axis. And on the y-axis, we know that x is equal to 0. So therefore, to find the invariant points, we're going to use, we can use either the given or the reflected equation because invariant points belong to both of them, but it is safer to use the given function, and we're going to substitute x by 0. So f of 0 would be equal to, let me just write the equation of the function here. So if we have f of x equals 2x squared minus 7x minus 4, so better use the given function. All right. Then we'll have 2 times 0 squared minus 7 times 0 minus 4, which is simply and fairly easy evaluation to do even mentally. So we have negative 4. Now remember, if f of 0 is negative 4, it means that x equals 0, y equals negative 4. And that's exactly what makes the invariant point in our case. So you can try the next questions on your own. I'll move on to the function gx. So again, we're trying to find g of negative x. So what that means now, we're going to have 1 over, I see x. X will be replaced by a negative x. Nothing else changes. And then plus 4. So this would be the equation of the rational function, or reciprocal as we call it. And if we want to, we can also simplify this a little bit more. And that is something that we're going to talk about even more extensively in the upcoming lessons. But I would prefer to rewrite this function as with a negative sign in the numerator. Always keep the negatives in the numerator. And then plus 4. It makes it easier to simplify. Now, both answers are equally, right, and but this would be considered more simplified or easier to use. Now, we're going to find the invariant points. So again, we don't need to explain this. We already know invariant points. This is over the y-axis. So over the y-axis, it means that x will be equal to 0. So we're going to find g of 0. And the function that we want to use is the original one, because we don't want to take chances. And then find g of 0. That would be 1 over negative 2 plus 4. Well, 0 plus negative 2, right? And that would be negative 1 over 2 plus 4, which is basically 3.5 or 7 over 2. Therefore, we're going to say the coordinates of the invariant point are at x equals 0 and y equal to 7 over 2. Now, next we have a square root function. So, and notice how with practice we tend to do things a lot faster, and our brain processes information faster, and that's a form of intelligence, and we know that. Now, kx equals root of x plus 3 minus 1. We're trying to find k of negative x. So that means that we have the square root of negative x and then plus 3 minus 1. And I get a very frequently common kind of reaction whenever I replace x by a negative x in here. Students think, miss, but we cannot have negatives in here. Well, you don't know what x is, right? So x can be a negative with another negative makes a positive. So it's just a variable. It is not a negative number, not necessarily. So if you want to, you can factor out the negative 1, but this would be a good enough answer in this case. So if you did factor negative 1, then that would look like k negative x equals the square root of negative 1 times x minus 3, and then minus 1. You don't need to take this one out. You cannot take this one out, by the way, because it is a negative number, right? You can simplify more. Now, let's find the invariant point. So for invariant point, we're going to make x equal to 0 because we are on the y-axis, and we're going to use the given equation or the original equation, which is root of x plus 3 minus 1, and k of 0 will be equal to the square root of 0 plus 3 and then minus 1. So that would be root of 3 minus 1, and this would be the exact value. So invariant point will have the x coordinate, the y coordinate of root 3 minus 1. That's the exact value. So we're going to say that 0 root 3 minus 1, or you can use a calculator and round this answer as well, right? And sometimes we will have to, because it is difficult to plot on the graph, for example, if we had the square roots of a number, right? So the square root of 3 is 1.73, and when we take away 1, it will become 0.73. So, or you can write 0.73. 0 is the x coordinate, and 0.73 would be the y coordinate. Now, I hope you found these instructions useful. Please practice, do your homework, and enjoy learning math. Bye for now.